This is the practice assessment for section 6.1 to 6.4. Problem number 1 says change 700 degrees to radians. When we change degrees into radians, we multiply the degrees by pi over 180. Remember that we said that 1 pi radians was equal to 180 degrees. So you're just going to multiply. This is like multiplying two fractions. So you get 700 pi over 180. And then in your calculator, you're going to reduce this part of the fraction. So you put in 700 divided by 180, math, enter, enter. And it reduces to 35 over 9. Don't forget to leave the pi in the answer. So the answer is 35 pi over 9. If you want to go the other direction and change radians into degrees, you would change negative pi over 12 radians into degrees by multiplying by 180 over pi. So the pi should cancel, so you're left with negative 180 over 12, and that's going to equal negative 15 degrees. For number 3, we're going to find the area of a sector, and I will give you this formula on your formula sheet, but you need to know how the formula works. So find the area of a sector if the central angle is 66 degrees and the radius is 12.1 yards, round to the nearest tenth. Now the first thing we have to do is theta must be in radians. So if you're in degrees, you're going to change it to radians. Here's the thing. You actually don't need to reduce it before you plug it in the formula. If you want to reduce it, you can. But the calculator actually ends up reducing it and giving you the correct answer. So if you just leave it as 66 pi over 180, then you'll be fine. The one thing I want to remind you is don't forget to square the radius. That's the one thing that students forget when they use this formula, is to square the radius, even though I'm giving you the formula. So you're going to do 1/2 times 12.1 squared times 66 pi over 180, and you should get approximately 84.3. Since it's an area, it's going to be in units squared, and the specific units for this problem are yards. Number 4, given a central angle of 76.4 degrees, find the length of the arc in a circle with a radius of 6 centimeters, round to the nearest tenth. So remember when you read the problem to look for what they're asking you to find. The length of an arc formula is S equals R theta, which can be confusing because most people don't associate length with the variable S. So theta in this problem must be in radians just like the last problem. So you have to multiply 76.4 degrees times pi over 180. What I would do is I would just leave it as 76.4 pi over 180 and then plug it into the formula. So the radius is 6, and you're going to multiply it by 76.4 pi over 180. And then you'll round it to the nearest tenth, and you end up with like 8.000 something. So we're going to say it's about 8 centimeters. Since arc length is a length, it's not in square units like area is. Number 5, find the area of a sector if the central angle is 7 pi over 12 and the radius is 2.6 meters, round to the nearest tenth. So first, I'm going to use the area formula. And I want you to notice that the angle is already in radians. That means I don't need to change it first. I'm ready to go plug this into the formula by doing 1/2 times 2.6 squared times 7 pi over 12. And I should get approximately 6.2, and the units of measurement in this problem are meters, and its area, so it's meters squared. Number 6, graph y equals cosine x for the interval 3 pi to 5 pi. So let's go back and talk about the graph of cosine x, because I also want to review the graph of sine of x to help you graph this interval. We only learned how to graph 1 period, I should say, of the cosine curve. And 1 period of the cosine curve looked like this. It started at 1 when x was 0, and then at pi over 2 it was at 0, 1 pi it was at its minimum, 3 pi over 2 it was on the x-intercept, and 2 pi it's back at the maximum. Some of the things we discovered about the cosine curve was that the maximums were at even pi's, and the minimums were at odd pi's, and the x-intercepts were at the half pi's. So if you want to graph from 3 pi to 5 pi, the way I would draw this graph, you know it goes from 1 to -1, and then I'm going to put this little mark here. What this little mark means is that I'm not starting at 0. I'm going to go from 3 pi to 5 pi. Well, in between that is 4 pi. This is 3.5 pi, which is the same as 7 pi over 2. So this would be 9 pi over 2. So how am I going to graph this cosine? Well, if you remember that the minimums are at the odd pi's, then my minimums must be here and here, which means my maximum is here, and the half pi's, it hits the x-axis. And there's my graph from 3 pi to 5 pi. Let's do this again. Let's graph y equals cosine x for the interval of -8 pi to -6 pi. Now you have to remember how the negative x-axis works. -6 pi would be here, and -8 pi would be here, because as you go further to the left, they get more negative. So in the middle must be -7 pi, and these must be my half pi's. So this one is -6.5 pi, which is -13 pi over 2, which means that this one must be -15 pi over 2. So the graph of cosine, it's at its maximum at the even pi's, it's at the minimum at the odd pi's, and it hits the x-axis at the half pi's. And there's my curve. Let's talk about sine x for a moment. Sine x, 1 period, looks like this. The graph hits the x-axis at all the integer pi's, and then it fluctuates whether it hits the maximum or the minimum at the half pi's. Now, if we look at the graph on the left-hand side of the x-axis, in order to follow the pattern, the graph would first go down and then up, and then back down again. So this is how it's going to work. If you're at an even pi and you draw the graph to the left, at an even pi, the graph will always go up first. But if you start at an odd pi, the graph will go down. The reason I'm mentioning that is because I'm going to go back to this problem. Except now I'm going to change it to sine of x from 3 pi to 5 pi. How would I know what the graph of sine of x is going to look like from 3 pi to 5 pi? Well, we know that the sine graph hits the x-axis at all the integer pi's. Well, does the graph go up or down when it starts at 3 pi? For the sine graph, if you start at an odd pi, you go down first. Oops, I went too far. You would go down first, and then go to 0, and then go up, and then go to 0. So from 3 pi to 5 pi, the sine curve would look like that. How about if I did the same thing here? from negative 6 pi to negative 8 pi. What would the graph of sine of x look like? Well, the sine graph hits the x-axis at all the whole pi's, and then going to the left, if you draw it this way, so negative 8 pi is an even pi, so from an even pi it would always go up first, and then it would go down. And that's what the graph of sine of x would look like, from negative 8 pi to negative 6 pi. So a good way to look at it is that if you start at an even pi and you go from left to right, it'll go up first. And if you start at an odd pi from left to right, it would go down first. For number 8, y is equal to negative 3/2 cosine of 5 theta. We want to first state the amplitude. Remember, the amplitude is always positive, so it's positive 3/2. Now we want to do the period. Well, to find the period, we use 2 pi over k. In this case, k is 5, so the period is 2 pi over 5. Now we're going to graph one period of this curve. So I always like to draw a very cheap graph. We're just going to call these tick marks 3/2 and negative 3/2. You don't have to graph 1, 2, and then plot 3/2 between them. The graph is going to start at 0, and it's going to end its period at 2 pi over 5. So what's half of 2 pi over 5? It's 1 pi over 5. What's half of pi over 5? Well, in your calculator, if you want your calculator to help you out here, don't put pi in your calculator. Do 1/5 and then divide that by 2, and then hit math, enter, enter, and it'll tell you that it's 1/10. So in our case, it's going to be 1 pi over 10. So this is going to be 3 pi over 10. So it's a cosine graph, and cosine graphs either start and end their period at their maximum or minimum. Because the function's being multiplied by a negative, it gets reflected over the x-axis. So it's going to start and end its period at negative, or at the minimum. And in the middle, it'll hit its maximum. And in between those, it will hit the x-axis. When you draw your graph, I need to see that the amplitude has been marked. I need to see the 5 tick marks. The first one is 0. The last one is the end of the period, and then you have to find the 3 in the middle. And then I want to see that those 5 dots on the graph for the one period have been graphed correctly. Let's do this again. The amplitude is 0.7, that's the easy part. But the period is 2 pi over k. What's k in this case? Remember that 3 theta over 2 is the same as 3/2 theta. So the period is 2 pi over 3/2. 3/2 is 1.5, so if you want to do 2 divided by 1.5 and then hit math, enter, that's fine. Using basic mathematics, we would simplify this by multiplying by the reciprocal of the denominator, in which case we would get 4 pi over 3. Either way, you should get 4 pi over 3. Remember, if you're going to simplify your fractions using your calculator, don't put pi in your calculator. Just do 2 divided by 3/2, math, enter, and then put pi on the final answer. Okay, cheap graph. We're going to call that 0.7. We're going to call that negative 0.7. We're going to start at 0, and we're going to end at 4 pi over 3. What's half of 4 pi over 3? 2 pi over 3. What's half of 2 pi over 3? 1 pi over 3. So this one must be 3 pi over 3. But 3 pi over 3 reduces to 1 pi. Now I'm ready to draw my graph. It's a sine graph, so the sine starts here, And since the amplitude in the equation starts with a positive, the graph is going to go up, middle, down, middle. Number 10. Write an equation of the sine function with an amplitude of 8/5 and a period of 5 pi over 3. So, the general equation for sine is a sine k theta, although sometimes we use x and sometimes we use t. I will accept any of those three input variables. Since we don't know what the graph looks like, we're going to start off the amplitude by saying plus or minus 8/5. We have to use plus or minus unless we know what the graph looks like. Next, we have to figure out what k is. K is not 5 pi over 3. Unfortunately, you do have to do some work. You're going to set 2 pi over k equal to 5 pi over 3. This is a proportion. We're going to cross multiply to solve. So I get 5 pi k equals 6 pi. In order to finish solving for k, I need to get rid of 5 pi. That goes away by dividing. And then the pi's cancel, so I'm left with 6 over 5. And this is the equation for the sine function. Again, the amplitude does get plugged in as long as you put a plus or minus sign in front of it. But 5 pi over 3 is not k. You must set it equal to 2 pi over k and then cross multiply first. Number 11, parts A, B, and C are all going to go together. Part A says determine the number of radians in 3.8 revolutions. Remember, we've done this before, but we did it with degrees. If we wanted to find the number of degrees in 3.8 revolutions, that's the same thing as saying, if I turn around in a circle 3.8 times, how many degrees will I have gone through? And then we would have multiplied it by 360 degrees. But since we're doing this in radians instead, what is the radian equivalent of 360 degrees? It's 2 pi. So you're going to multiply this by 2 pi radians. And we're going to get 23.9 radians. Now that you have that answer, you need it to do part B. Determine the angular velocity for part A if it rotates for 2 minutes. The formula for angular velocity was omega equals theta over t. So theta is in radians, so we need our radians from the previous part, and then t is your time. So when I divide this, my final answer will be in radians per minute. So 23.9 divided by 2 is going to give me about 11.9 radians per minute. Might actually be 11.8. I don't know. Something like that. Then you need that answer to do part C. Determine the linear velocity if the radius is 3 inches and we want to answer in feet per second. Okay, so linear velocity is r times omega. So if you know the number of inches, remember this is 3 inches, let's do this, 3 inches, times the angular velocity, which is 11.9 radians per minute. When you multiply these together, you're going to get inches per minute. So you're going to get 35.8 inches per minute. But I don't want the answer in inches per minute. I want the answer in inches per second. Feet per second. So we're going to do dimensional analysis, just like we did in chemistry. In order to change inches into feet, I'm going to change this to 1 foot is 12 inches, so that inches cancel. And then I need to get rid of minutes in the denominator and make it seconds. There are 60 seconds in 1 minute, and that'll make minutes go away. When I multiply these together, my final answer will be in feet per second, but I need to multiply 35.8 times 1, but I need to divide that answer by 12, and I need to divide by 60. How did I know I'm going to divide? Because it's in the denominator of a fraction, right? And so anything in the denominator of a fraction gets divided. So 35.8 divided by 12 divided by 60 is about 0.05 feet per second. And that is the practice assessment for 6.1 to 6.4.